This is video 3 on molarity for chapter 12. And what molarity is, and its symbol is a capital M, what molarity is a way of measuring how concentrated or dilute a solution is. And so when we talk about concentration of solutions, we could say, like if you've made Kool-Aid, you can talk about Kool-Aid that's either too sweet or too watery. The too sweet stuff would be too concentrated. The too watery stuff would be too dilute. And that's an example of just very qualitatively describing concentrations. But we can actually tell you an actual concentration of a solution by doing some measurements, or some calculations. So we use the formula that molarity is equal to the moles of the solute. Now remember, the solute's what's being dissolved, and that is divided by 1 liter of solution. So moles of solute divided by liters of solution will give us molarity. And the units for molarity then are in moles per liter, or we can simply write just a capital M. Now you guys have probably seen this before. In our labs we've used hydrochloric acid before, and a lot of times the label on the bottle will say 6M HCl. And what that means is that we have 6 moles of HCl for every 1 liter of solution that we're using. And so that's an example of the molarity of that acid. When we buy it from the manufacturer, we buy it as 12 molar. So when we buy it, it's 12 moles of HCl per 1 liter, and then we dilute it by adding water to get it down to 6, or to whatever concentration we need it for various labs. So that's what molarity means. Now, if you think of it as a formula, much like density, if you remember in 9th grade you learned that, and in this year too, density is equal to mass divided by volume. If you know any 2 of the units, you can find the third. And so the same is true with molarity. If you know any 2 of these quantities, you can find the third. So if I know the moles of solute and the liters of solution, obviously I can find the molarity. But if I know the molarity and the moles of solute, I could find how many liters of solution there would be. Or if I know the molarity and the liters of solution, I could figure out how many moles of solute there are, and possibly even how many grams of solute there are, because you guys should all know how to go from moles to grams. So we're going to try a practice problem. Practice problem number 1 is already typed up for you on your sheet, and it just says a solution is prepared by dissolving 7.75 grams of C6H12O6 in enough water to make 450 milliliters of solution. What is its molarity? Now, it probably doesn't hurt to identify which one is the solute and which one is the liters of solution, although this probably is pretty obvious to you. This 450 milliliters of solution, that's going to give us our liters of solution eventually. And this 7.75 grams of C6H12O6 is our solute. Now, you're going to have to make some changes to what we've got here, because if you notice, the formula doesn't ask for grams of the solute, it asks for moles of the solute. So we're going to take our grams of our solute and we're going to change that from grams into moles. And you should all know how to do this, hopefully at this point in the year. And what you're going to do is add up from the periodic table all the individual molar masses of the carbons, the hydrogens, and the oxygens. And you should get 180.18. And when you do this math, you should be able to get, with 3 significant digits, and these zeros don't count, 0.0430. Now that last 0 does count. Moles of C6H12O6. So that's our first step, was convert our solute from grams to moles. Now if we look at our second part of the problem, we were given 450 milliliters of solution. Now we cannot use milliliters of solution, we have to use liters. So we want to change from milliliters to liters. And for every 1 liter, there are 1,000 milliliters. So that is 0.450 liters. Now to find our molarity, what we're going to do is take, our molarity is going to be equal to our moles, 0.0430 moles, divided by our liters of solution, 0.450 liters. And our answer should give us 0.0956 molar. And you could either write molar with a capital M, or you could leave it as 0.0956 moles per liter. Either answer is absolutely okay. So that's one example. Now example 2 is a little different. This one is asking you the mass of NH4Br that is required to prepare 250 milliliters of a 3.75 molar solution. So if you look at what you were given in this problem, you were given the volume is 250 milliliters. You were given that the molarity of the solution is 3.75 molar or moles per liter. Now, whenever you do a math problem with molarity in it, you should always write the units out the long way, moles divided by liters, because that way you can see what cancels. Now, if you think of the formula that I gave you, molarity equals the moles of the solute divided by the liters of the solution. If you look at what I was given to you, or given in the problem, you were given the liters of the solution, and you were given the molarity. So our job is to find the moles of the solute. Once we find the moles of the solute, we can change that to grams. So how am I going to find this? Well, I'm going to multiply both sides by liters. So I'm going to notice that I can get my moles of solute will be equal to my liters of solution times my molarity. So I'm going to do that math. Now, liters of solution, 250 milliliters is the same as 0.250 liters. So 0.250 liters, it has to be in liters for this to work, times the molarity of 3.75 moles per liter. And that's why it has to be in liters, or those numbers won't cancel. When I get that done, I get an answer of 0.938 moles. And that's moles of the solute. Now the solute happens to be NH4Br. So if I want to change that into grams, 0.938 moles of NH4Br, you're going to multiply by the grams per mole. So you're going to add up an N, 4 H's, and a Br, and you should get 97.95 grams. And so your final answer with 3 significant digits should be 91.9 grams of NH4Br. And we can practice more of these problems tomorrow in class.